For nearly a century, quantum mechanics has relied on a ghost in the machine. The standard interpretation treats the observer as an external, passive eyeball, a mathematical convenience that collapses wavefunctions without participating in the physical forces of the system itself. Thermodynamics offers a different perspective. In systems pushed far from equilibrium, chaos spontaneously self-organizes into highly structured forms. The consciousness resonance framework bridges these two domains. It removes the philosophical vagueness of what constitutes an observer and replaces it with strict thermodynamic parameters. Under this framework, the observer functions as a thermodynamic entity, an entropic condenser. Observation is the literal physical transformation of external informational disorder into internal structural coherence. To understand awareness, we must stop treating the observer as a mathematical anomaly floating outside of nature. The observer is a measurable, mechanical machine, strictly bound by physical law. This diagram illustrates the primary entropic criterion for observation. For any system to qualify as an observer, it must actively lower its internal entropy, represented here as ds int by dt less than 0, while simultaneously increasing the entropy of its external environment. By acting as a local entropy sink, the system redistributes disorder outward. This flow allows the bounded structure to extract usable information from external thermodynamic gradients. This physical extraction of order from disorder mirrors the concept of biological negentropy. Erwin Schrödinger established that living systems sustain themselves by feeding on negative entropy. To maintain this continuous flow, the observer must exist in a permanent state of thermodynamic disequilibrium. A completely static system that has reached equilibrium with its environment cannot observe anything. It lacks the gradient flow required to convert entropy into information. Awareness begins at the exact physical boundary where a structure successfully pumps disorder outward to maintain its own internal architecture. The architecture is a network of coupled oscillators. Initially, their phases rotate at independent, chaotic speeds. Introducing coupling strength forces mutual interaction, pulling them toward a shared rotation speed, Kuramoto synchronization. As phase alignment locks into perfect synchronization, internal entropy plummets to a minimum. This synchronized state creates an internal resonant cavity. It acts as a structural barrier that naturally filters out ambient thermodynamic noise. The locked phase operates as an epistemic sieve. Only incoming frequencies that share specific mathematical relationships, coprimes, with the established network can integrate into the structure. A highly dense, tightly coupled network can maintain stability against massive interference, while a weakly coupled network shatters under minor stress. This network density strictly limits the system's observational bandwidth. Whether we examine the phase relationships of subatomic wavefunctions or the firing patterns of macroscopic neural circuits, both utilize this exact mathematical architecture. Observation requires no conscious intent. It requires only sufficient structural coupling to enforce internal phase alignment against ambient thermal noise. But external reality is an intensely noisy environment. Surrounding entropy gradients are relentless, continuously bombarding the bounded observer from all directions. This external kinetic shock physically knocks the network's oscillators out of their synchronized phase lock. This sudden internal disruption registers as epistemic surprise, a sharp spike in the network's variational free energy. Governed by the free energy principle, the system faces an immediate imperative. It must automatically minimize this surprise, or the entire structure will disintegrate. To defend itself, the network utilizes its internal composite modes, absorbing the variance of the shockwave across its available degrees of freedom. It dynamically shifts its internal coupling weights, generating a counter-resonance precisely tuned to the frequency of the disruption. During this rapid transition, the network operates in a superposition of potential states, searching its mathematical constraints until it discovers a new, stable configuration. Perception of the outside world is physically just the network measuring its own internal phase disruption and struggling to correct it. Resolving that perturbation and re-establishing phase lock is not a passive mathematical trick. It demands physical work. This act is governed by a strict thermodynamic energy-entropy coupling equation. The local ordering mechanism extracts usable energy and directly pumps the resulting heat into the external environment. This mechanism perfectly satisfies the second law of thermodynamics for open systems, where internal order is paid for by increasing global disorder. This continuous cycle of perturbation, physical work, and heat exhaust forms the fundamental metabolic engine of awareness. If a system cannot successfully radiate this heat outward, it will suffer rapid decoherence and entirely lose its capacity to observe. We see this thermal exhaust at the macro scale. The human brain requires massive caloric input and produces significant heat during intense cognitive focus. Because observation requires physical work and generates heat, it is strictly bound by thermodynamics. Infinite or perfect awareness is energetically impossible. Once the heat is exhausted and the network restabilizes, the resolved information has to go somewhere. It undergoes symbolic condensation. The perturbed oscillators lock into a novel, highly stable geometric arrangement that is entirely distinct from their original pre-impact state. This new low-entropy representation acts as a physical, structural cache of the past event. The mechanics here mirror Bose-Einstein condensation in quantum physics, where thermal energy drops and distinct elements collapse into a singular, coherent quantum state. This physical caching provides the foundation for predictive processing and anticipation. By accumulating these stacked condensates, the network uses its own hardened structure to project forward, preemptively generating counter-resonances to resist future similar perturbations. The moment the resonance collapses into a specific, stable condensate, it breaks the symmetry of the system's potential states. This collapse instantiates the subjective now by creating a sharp discontinuity between the cached past and the projected future. Memory constitutes the literal structural scar tissue left behind after an oscillator network successfully defends its internal coherence. Because this mechanism depends purely on network size, coupling strength, and phase stability, observation is entirely scale-independent. We can trace this unbroken chain upward. At the biological scale, microscopic chemical gradients and cellular metabolic cycles operate as localized entropic sinks. Stepping up to the cognitive scale, the exact same mathematical model maps directly onto the sensory processing pathways of dense neuronal fields. Expand further to the planetary scale, and we see biospheric systems functioning as massive oscillator networks, stabilizing solar entropy to maintain global ecological balance. The exact same mathematical capacity function, C-OBS, governs the thermodynamic boundaries of all these strata. A human brain and a planetary ecology differ as observers only in the magnitude of their coherence capacity, not in their physical thermodynamic function. This model describes reality as the simultaneous aggregate resonance of all observer networks interacting at once. It operates as a continuous closed feedback cycle. External disorder forces resonance alignment, generating internal order, which expels coherent output back into the environment. Countless entropic sinks process this cycle simultaneously, filtering physical reality through overlapping fields of multiplicative resonance. This is the physical mechanism behind physicist John Archibald Wheeler's participatory anthropic principle, the mathematical reality that the universe requires observation to actualize. Observation acts as the physical process through which the universe structurally organizes itself.